Okay, I want to thank you for joining us today for our webinar. My name is Steve Kadivnik. I'm the technical representative with Artistic Skylight, and the theme of our webinar today is Skylights and the Building Envelope. Just to summarize some of the presentation details, we're going to talk about skylights and the benefits of natural daylighting to enhance productivity and health and well-being. We're going to talk a little bit about energy efficiency and SB 10 code compliance as it's related to the Ontario Building Code, product testing with skylights, specifically the Energy Star program and the North American Fenestration Standard, fall protection design and testing for skylights, AAMA guidelines for proper slope glazing installation, some installation best practices, and a case study. So what are the benefits of having skylights in the building envelope? Well, let's first talk a little bit about the future of our electricity supply. In Ontario, we have seen a dramatic rise and increase of prices, but this is across the board for the entire country. Over the last few years, we have seen increases. According to, just in Ontario, according to the Fraser Institute, there's been a 70% increase for commercial and industrial customers in Ontario, which is a tremendous amount. Projected annual increases of 3.9% each year for the next 10 years, according to the Grid Operators Ontario Planning Outlook report. The IESO warns that Ontario could experience electricity shortfalls within the next few years, and they're projecting 1,400 megawatts by 2023 and 3,700 by 2025. So very large numbers, no doubt. And we all know the effects of shortages. There would be an increased power interruption, power failure, blackouts, brownouts, and all these things can be costly to business, no doubt. So skylights in building design. Well, studies have shown that daylighting with skylights reduces as much as 1/3 of total building energy costs. And according to the Professor Marilyn Anderson at the Department of Architecture at MIT, she stated that depending on the building and how it's used, a good daylighting strategy can reduce the need for energy-consuming electrical lighting by 20 to 80%. On a sustainability measure, by reducing the need for electric consumption for lighting, the use of natural daylight to illuminate spaces contributes to reducing greenhouse gases and slowing fossil fuel depletion. So really it's a conscionable reason to look at the opportunity to use more daylighting with sunlight rather, to have a less reliance on artificial lighting, therefore reducing our need for energy. And this is really what we're talking about and focused on, is energy savings for not only Ontario, not only Canada, but the entire world. And as designers, architects, engineers, we all have a conscionable reason to contribute our ideas about how we can do this and use different tools and products at our disposal to incorporate into our building. And there's some other benefits of using skylights. Recent studies have shown that retail stores with daylighting sell more merchandise. Down in the US, they've done a lot of studies with this, and they have an example of one retail chain that achieved a 40% higher sale with skylights that provide that daylighting, and yet another retail chain increased sales by 6% in stores that had skylights installed. So some great reasons for retail industry to consider using more daylighting. So if you're in a specialty of architecture that deals with architectural spaces with retail chains, different places like shopping malls, we see lots of skylights used in a lot of these facilities already, and there's a good reason for that. But we certainly could incorporate it even further. Also in another area is in classrooms. Students were found to perform better in daylit spaces, and they did a study where they performed 21% better in classrooms with daylight compared to those without. So another really super great reason, if we work in the educational sector, in that particular vertical market of the education sector, colleges, universities, schools, daycares, all of these areas could benefit using more daylight, because it can ultimately help students perform better. And what are not a better reason to think about that and how we can help our students in classrooms. We're also going to talk about benefits of skylights in healthcare facilities. And there was an interesting study done in the Aga Khan Hospital by the School of Architecture in South Korea, Hanyang University. It was an architectural study on the relationship of skylights and patient satisfaction. And some of the objectives of the study was to identify the mechanisms by which skylight impacts human health and performance, and assess whether the amount of natural daylight in a hospital room modifies a patient's physiological health and the quantity of pain medication used. So very interesting stuff here. And in the study, some of the facts of the study were some of the patients and hospital staff participated in a survey, a type of questionnaire, and it was regarding the aesthetics of their hairspace in relationship to their health and well-being. Crucial findings were the quantitative observation and opinion compared with the numerical data of luminance levels of daylight measured and recorded through the recovery areas in the hospital ward at different intervals. So basically, in layman's terms, they recorded the levels of luminance expressed in a numerical value, and then compared that to how patients and staff reported feeling. So, and they did this over a spread of time, and they recorded all this data. Another fact or something that was reviewed was how sunlight affects our principal mechanism that controls the body's rhythms, and this is known as the body circadian system. And the circadian rhythm is a natural internal body process, and it regulates the sleep-wake cycle, and this roughly repeats every 24 hours. So sunlight impacts this mechanism. The research study also explored the role of architectural building design in improving the quality of patient environments to support healing and stimulating feelings of well-being and satisfaction. And we know patients that feel better heal better and quicker. The conclusions essentially of the study were the results from the survey about patients through accelerated healing, and with the presence of windows and skylights, they had better sleep and better mood compared to the quantity of UVs received. So in other words, the more they received natural daylight, the UV from the natural daylight, the better the mood, the better the sleep they had. The study also found the patients exposed to an increased intensity of sun had less perceived stress, marginally less pain. And they even found out that they took a measured amount of 22% less analgesic medication per hour. So that's quite an outstanding fact from the study. And ultimately, the final conclusion was adequate and appropriate natural daylight is crucial for the health and well-being of all patients and staff in healthcare settings. It must be incorporated into the lighting design. So again, here's another great reason how we can work in our building design, how we can incorporate natural daylighting into work in conjunction with artificial lighting, and being able to use that more through the day to really help patients in healthcare settings. Now, some additional studies. Again, another study on the impact of light on healthcare, and this was done by Anjali Joseph, who is working for the Center of Health Design. And basically, the key findings of the study was the objective was to find how light affects health and well-being and the health outcomes in these different settings, and how the daylighting can enable the performance of visual tasks, managing the body circadian system, mood, insight, and allowing significant changes of chemicals in the body. The summary over to the right from that study was they found that patients experienced less perceived stress, they experienced less pain, they took less medication for analgesic medication per hour, and as a result, there was a 21% less medication cost to the hospital facility as a result of this. So fantastic research. Finally, something that we're all very familiar with in the last little while, and how many of us have seen that little diagram or drawing of the virus? And the New York Times published an interesting article on May 13 of 2020, The Benefits of Sunshine for Mind and Body. And the article basically featured scientists that are exploring how sunlight might be able to combat the coronavirus directly as it does for other viruses. This one particular specialist, Paul DeBiche, an aerobiology specialist with the Department of Homeland Security, and along with other colleagues, he published a paper in November that found that flu viruses are rapidly inactivated when exposed to UV radiation and sunlight. His team and others are also currently conducting research to determine whether UVs from sunlight also destroys the COVID-19 virus or mitigates its effects. So some really powerful research being done into how the sun or the sunshine, the rays from the sun can help control virus outbreaks. And this may become more and more important as we go along, as COVID-19 develops and society is trying to find a way how we can get it under control, and maybe even future viruses. So again, another incredibly important reason why we should consider how we can bring more sunlight into a building, whether it's through windows or overhead lighting, such as skylights. So skylights are a great way to let the daylight in. As you can see, there's all sorts of different ways we can do this with different types of materials. We can use things like acrylics and polycarbonate plastics, and of course glass. There's all sorts of technology available in the market for slopes, for fenestration. Shapes can be flat, they can be domed, they can be barrel, vaulted, pyramid style. But most importantly, above all else, skylights can also be energy efficient in conjunction with all these features. We're going to talk about some of the different options that are available in project designs to give you some inspiration and ideas about what can be done with skylights. So this is mostly pictorial. I'm just going to scan through different pictures of different types of skylights and the different features that are available. These are skylights that are installed with curbs. As you can see, there's different shapes, there's different tall types of curbs. Sometimes we need a taller curb, so these things can all be specified. But it allows for an integrated design. We also have a category of structural architectural, which takes in a lot of different materials and shapes and sizes. I'm just going to go through these pictures just to give you some idea of some of the different configurations and options and designs and glazing that can be used to either provide a very clear view or an obscure view. In this case, it's clear. That would be clear glass, of course. But there's different ways that we can incorporate glazing into our overhead slope glazing into our projects. And whether it's a residential project, commercial, industrial, institutional, there's all sorts of different ways that we can do this, as you can see. And of course, we even have some more complex designs that can be incorporated. You can see how this unit is integrated into a very old structure building. And again, this is a way that we can enhance the old and the new to be functional. And this would be a residential setting. Beautiful natural daylight coming in through that space. It does provide a very pleasant environment, no doubt. And this is what we call a sloped lean-to type skylight, which leans into the wall. There's lots of ways this can be done. It obviously takes a lot of ingenuity to make everything watertight. But certainly if it's done right, there should be no issues. And we will touch on a little bit about water tightness and leak stigma, the stigma of leaking skylights. We will talk about that in a later slide, of course. Lots of different possibilities. We can use all sorts of different types of materials to achieve the goal, whether it's energy efficiency, maximizing daylighting, keeping the budget down. We don't have to spend a fortune to do a great job of bringing daylight into a space. You can even do the funky circular units, which were very big in the 80s. We're seeing kind of a resurgence of circular skylights. They're sort of made a comeback, but they're kind of in neat shape. And then we can even do thermal formed pyramids and octagons as opposed to a structural pyramid glass aluminum type traditional. This is more of a kind of a one-piece design. And another way to bring light into a space is through the roof hatch, is in having a skylight hatch. Typically these are steel hatches, but as an alternative you can certainly specify skylight hatches. It's a great way to bring daylight. Typically these hatches are installed in little corridor areas or dark, dingy janitor closets and maintenance rooms, and it's quite dark often in there if it's illuminated very well. And how nice would it be to have that overhead skylight hatch integrated so that you can see where you're going when you're walking up that ladder. Now another category of type of way to bring daylight into a space is tubular daylighting. We've seen these used a lot in institutional where we don't have the opportunity to frame an interior opening like a vaulted light well. So we can certainly bring the light through a tube. There's lots of ways we can do this. There's some examples of warehousing and a gymnasium type pool facility that are using the tubular daylighting. But there's a lot of possibilities, a lot of options with this system. There's also lots of different ways to flash it on the roof to make sure everything is watertight and meets energy standards and codes. Lots of different possibilities on how to integrate that into the roof system. And some before and afters in a typical residential space, this could be a commercial space as well, of the difference in adding a small tubular daylighting and even in a residential setting. Moving on to another category of skylights and energy efficiency. So skylights that are selected for a building project can be specified to offer high performance energy efficiency as referenced by the following: the Energy Star program and the Ontario Building Code. And of course, the Building Code applies, National Building Code is across Canada. In Ontario, of course, it's governed by the Ontario Building Code, but in your respective province, if you're outside Ontario, of course, it's governed by your building code in your local jurisdiction. In this case, we're talking specifically about the program in Ontario. The Energy Star program, we're all familiar with that logo. We've seen that logo on a lot of different products. If you go onto the Natural Resources Canada website, you will find a whole list of category products that meet the Energy Star program, Skylights included. Basically, Energy Star is the mark of high efficiency products in Canada. It's a familiar symbol, so we know when we see that, we're buying an energy efficient product. They have to meet strict technical specifications for energy performance. It has to be tested, certified, and usually these products are in their top 15 to 30% of their class for energy savings. All these, again, products have to be tested and they have to be certified, and it's an independent third party that comes in to evaluate a manufacturer's, they basically do an annual audit to make sure that they meet all the requirements of the program. Now, what's in a label for the Energy Star program? Well, in Canada, the windows, doors, and skylight label has the following components. It has the actual symbol. It has the climate zone that shows where it's been certified for in different parts of Canada. We have different climate zones, so not every product is certified for every climate zone. And the values have to be verified and by a certification body. That certification body could include the CSA Group, Intertech, and Quality Auditing Institute. And in this label, there's the fenestration label, the NRCan Energy Performance label, and the certification body's permanent label or mark. This is what we call the temporary label that is shipped with the product that basically has the U factor, the solar heat gain coefficient, and the visible light transmittance, the manufacturer's name, and the CSA standard that the product's been certified to. In this case, A440.2, which is the most common. This is a permanent label. When it's shipped, the product has this label and permanently installed on the frame to identify it as an Energy Star product tested by an Energy Star laboratory, certified laboratory. In Ontario, specifically, Ontario Building Code calls for specific values for thermal performance and solar heat gain of fenestration products. Now, again, in your respective province, if you're not in Ontario, you will have your own set of codes. They're pretty much similar across the board. Ontario uses what's called an SB10 supplementary standard. It gives specific values, but like I said, every province has a little bit of a different tweak on the building code requirements for thermal efficiency of skylights and windows. This is the SB10 table for the Ontario Building Code. It does specify things such as non-residential and residential applications, skylights with curbs, glass, without curbs, curb and plastic, and glass. And then the values are given for maximum U value, solar heat gain. So these are the requirements. If you're submitting plans and the plans examiner from the township asks you for verification of these values, you may have to provide supporting documentation. Now, there are many different ways we can achieve these high performance thermal values and lower solar heat gain. There's lots of different types of materials on the market that allows us to achieve this. Whether it's a type of plastic or a type of glass, there's lots of great high performance materials. We certainly can specify what's required to meet the values. Within the scope of North American Fenestration Standard, we have several different types of skylight products that would fall in this category: unit skylights and the tubular daylighting. This is basically the standard. This is the most current in the North American standard. It's the one that's the most current. It would be prudent to make sure that a product that you specify is able to meet this most current standard. We're going to see more and more of this being reinforced across the board in the next few years. This would be a sample of a test done for a product for the NAFS test, NAFS 17. And so these are basically the requirements: positive design pressure, negative design pressure, water penetration, air infiltration. So these are all values that the product has to meet and has to be tested to. I'm going to play a little short video. This is just a little demo of a water infiltration test on our Energy Star test program, just to give you an idea of some of the testing that's done with the products. This was shot with a cell phone camera, so it's a little bit on the shaky side, but it does make the point. Further to that, some commercial products are also tested. Some manufacturers have taken it on to take the NAFS testing to the next level and test even some of the commercial products. So it's a good idea to ask questions when you're researching using skylights in a commercial project. If you're concerned about performance and making sure that these units will exceed requirements like the NAFS standard, you certainly can ask for that data if it's available. Fall protection is basically something that's becoming more and more important. There currently isn't any specific code requirements in the national standards for fall protection as of yet for skylights. The only reference is OSHA, which is a US standard, but it's a guideline that specifies covers for openings or roof openings or protective screens. They're able to support twice an anticipated load without failure. So this is something that you may think about when specifying skylights, and a concern that the product can withstand an impact from a fall. We are seeing more and more of this becoming more important through different government agencies and local regional authorities looking at installations. Some manufacturers are now able to supply fall protection skylights that exceed OSHA requirements. These manufacturers may undertake third-party testing, so they'll hire a laboratory that will do these tests in different pressures and impact strengths to validate just how much the skylight can withstand as far as structural integrity. And they may test to exaggerated loads, things that may never actually happen in the real world, but they do that to demonstrate the capability. However, it must be noted that these are not certified products officially in any way as a fall protection device. You may still have to install railings. There's another possibility for skylights that are installed already and are in good shape, no need to be replaced. These screens can provide a very cost-effective, easy to install protection measure against accidental fall-throughs. So these fall screens can be installed over the existing curb. They don't penetrate the roof if it's a curb compression type design, therefore maintaining integrity of the roof warranty. As mentioned, you may still have to install railings. Some government agencies may challenge contractors on the safety merits of the installation, so they may still require roof safety railings to be installed around the roof openings. A common myth or stigma of skylights, as we discussed or mentioned earlier, is that, it's a very common question, a very common statement that I get at a lot of different trade shows that we do in the past. People come up and say, well, I'd love to install some skylights in this building or in this project, but I have a fear that they're going to eventually leak. And this is a common stigma of our industry. But what we find in our experience is typically product failure is rare, especially where tested units are tested to meet those stringent water infiltration tests through the Energy Star program, NAFs, and so on. We find a large majority of warranty claims installation is usually the root cause of water infiltration. So we're going to just touch on the AAMA guidelines for sloped glaze systems and proper installation methods for skylights. So these are some great guidelines that are given for designers and contractors for proper installation. The AAMA methodology is to use water control drainage systems, closed and open gutter systems, provide critical barriers with slope glazing systems, and increase thermal value to sill and curb. A properly fabricated and installed closed gutter system will control infiltrated water through the network of rafters, purlins, and drain out to the exterior of the air and water barriers. In a slope glazing system drainage, these typically can differ how they manage infiltrating water. Open gutters typically collect infiltrating water into the gutters mounted along the sides of the rafter and purlin members. Closed gutter systems collect infiltrating water into internal gutters, separated from the interior environment by air and water barrier seals, as you can see from these details. A closed gutter system drainage at the sill will allow drainage without penetrating air barrier between skylight and sill. So you can see there's an integrated water vapor barrier. This can be typically like an ice water shield. Of course, we have a sheet metal membrane support, and this will allow for proper drainage. Critical barriers in slope glazing system. The most critical barrier when dealing with moisture penetration at the sill of the skylight is the air and vapor barrier. Typically this will restrict exterior climates from mixing. It'll keep the weeping water from the system flowing to the exterior of the curb. The water shedding surface or the exterior face of the skylight also requires materials and components that perform control functions of direct weather. Properly applied face seals with structural glazing silicones such as Dow 795, EPDM gaskets, and Tremco butyl butyllithium 2 tape. So some of the critical barriers in slope glazing system, we can see that there should be a water shedding surface. This is all demonstrated by the different dotted line and solid lines. A water resistive barrier, an air barrier, and a vapor retarder. Here's another type of curb design. This is more with the sort of the unit skylight. Again, we're incorporating these water shedding surfaces. So we'll have our water resistive barrier, which will be typically our roof membrane, an air barrier, which typically will be some sort of a gasket that will be applied on the curb to inhibit any air infiltration. So we typically, most fan manufacturers use some type of neoprene gasket in this installation. A vapor retarder, and then of course we have a whole condensation weep system that allows the condensation to weep. And this is based, of course, on the rain screen principle. And of course, the water shedding surface ultimately is your flashing. Now, what we've seen a lot happen in the failures is that flashings typically sometimes are correctly installed. They're not supposed to be installed on top of the frames of the units. They're supposed to be tucked under the retaining frame. We've seen flashing installed on top of the retaining frame, which will of course allow water to enter the curb system, and typically that's where there are some failures, and upon inspection we find that its installation usually is a root cause, as mentioned earlier. Case study. We're just going to highlight a case study of a skylight leak inspection in the city of Hamilton. The issue was the water was penetrating and entering the skylight system, of course damaging the drywall, potential for mold development. So this is an inspection photo. On inspection, these were some of the observations made by the inspector. First of all, upon removal of the pressure plates and counter flashing at the sill of the skylight, there's obvious signs that water is entering through the skylight system. Water is leaking into the system, flowing downward and collecting at the sill of the skylight frame. So really there was no air vapor barrier to create an airtight seal at the curb, frame and curb. There was no very poor insulation at the sill and curb. and the continuous purlin and rafter was not cutting through the purlin. So all these things add up to problematic issues. Further to that, the system does not provide proper weeping of the moisture accrued from either water penetration or condensation, as it should in a typical rain screen principle. The leakage and condensation must be collected and drained to the exterior with a continuous drainage system consisting of interconnected closed gutters and sill flashing systems. So if done properly, we shouldn't see failures, but in this case, it was not done properly. Some of the inherent issues with the current system: the existing rafters do not follow through the purlins at the sill for proper drainage. The curbs do not have any vapor barriers separating the interior air from the exterior, and the curbs and sill flashings existing do not have adequate insulation, reducing thermal performance. Again, if these things were done correctly from the get-go, there wouldn't be any problems or issues. So conclusions for remedial work. After complete removal of all the caps, pressure plates, and flashings, it was recommended that all seals and glazing tapes and gaskets be replaced with new. This would allow the water shedding surface barrier, making the system as watertight as possible. And at the same time, all the existing glass units would be replaced with high-performance insulated glass units, which provide better control of heat transfer. And by doing that, we help further reduce condensation. The application of a high-grade air vapor barrier, such as Tremco ExoAir at the sill of the skylight curb, is critical to the overall performance of the slope glaze system. When it's properly applied, it will seal and transfer water to exterior of the curb and make the system airtight. The insulation installed at the sill and curb must be adequate and properly fitted between the metal deflector panels, and of course after wrapped with an air vapor barrier, and the skylight enclosure flashing panels. So just to summarize our presentation today, incorporating skylights into the building envelope can provide numerous benefits. We talked about energy savings, how using skylights can allow us to use less artificial lighting, therefore reducing our energy consumption and ultimately helping the environment. We heard about retail stores, how they can benefit from increased sales by incorporating more daylighting. Students in school perform better with daylighting in classrooms. Patients in healthcare facilities heal faster and better with less medication when they're exposed to natural sunlight from windows and skylights. Natural daylighting from the sun can help control and maybe even kill viruses and mitigate their effects on human health. And finally, when skylights are designed and installed correctly, should perform trouble-free for many years throughout the lifetime of a building while providing all of the benefits that we just discussed and more. So I want to thank you for your attention today to our webinar presentation. Hopefully you've learned a few things about skylights and how we can use them to benefit the building envelope by increasing energy efficiency, but a whole lot of other benefits. If you have any questions, feel free to visit www.artisticskylight.com for more information, and I'm sure you'll find a lot of very valuable information there on helping you with your project. Thank you and have a great day.